Okay guys, so today we're going to do 5.3. We're going to use reasoning and some skills to compare fractions. So we're going to decide if this side's greater or this side's greater or if they are the same. Here's 4 problems for you to try, but it's more than just putting one of those symbols in. It's about being very confident about which one's larger. So for each one, I'm going to show you 2 ways. I'm going to show you the skill that works every time, and I'm also going to show you how to reason a little bit. So for question 1, when I look at this, I can look at these 2 fractions and I can reason. Now I notice they're both less than a whole because 3/3 is a whole and 8/8 is a whole. So I can't use the whole to figure it out. But I do notice this. If I have 8 pieces and 4 are shaded, then I have half the cake. This is 1/2. This fraction, on the other hand, I have 3 pieces in the whole. Half of that would be half of 3 is 1.5 of those pieces. If I have 2 pieces, that's more than half. So 2/3 is more than a half, and 4/8 is a half. So if I'm trying to justify my reasoning, I can say, well, that's more than a half, and this one is 1/2. Now, if you're unable to figure that out, to think about it that way, there's another way we can do this. And this is a strategy we're going to use the rest of this unit. So I'm going to get equivalent fractions for both of these. So I'm going to times these each by a whole. And I'm going to try to get a fraction that's easy to tell which one's bigger. I'm going to try to get these to have the same denominator. So how I think about this is I'm going to think about my 3's facts and my 8's facts. Now, it is not necessary to write all of your 3's and 8's facts, but some kids need to see it. 15, 8, not 12. 8 plus 8 is 16. 16 plus 8 is 24. So I think about my multiples, right? I'm trying to think of what is a number that both 3 and 8 can go into, okay? So with 8, I've gotten to 24, so I'm going to keep going with my 3's a little bit. 18, 19, 20, 21, 22, 23. Aha! So the smallest number these both go into is 24, which means I can get an equivalent fraction for each of these that has a 24 in the denominator. So I think, well, what times 3 equal 24? 1, 2, 3, 4, 5, 6, 7, 8. Oh, yeah, 3 times 8. This goes to show why our math facts are so important. Now, this has to be 8/8 because in order for these to be equivalent, as we've talked about in previous lessons, 2/3 times 1 equals 2/3. So 16/24 is the same thing as 2/3. I'm going to write it up here just to remind myself. 2/3, oops. 2/3 is 16/24. But down here, what times 8 equals 24? Well, 8 times 3 was 24. Oops, I'm going to make this blue just so. So to make this one whole, it would have to be 3/3. 8 times 3 is 24. 4 times 3 is 12. So I've just proven that 4/8 is 12/24, which makes a lot of sense because 12 is half of 24. So if I have 12 shaded out of 24 in the whole, that's obviously a half. So now I can tell which one's bigger. What's bigger, 12/24 or 16/24? 16/24. And because 2/3 is 16/24 and 4/8 is 12/24, then we have proven that 2/3 is bigger. So that was 2 different strategies. This one was using my number sense. This is half, this is more than half, so this must be bigger. And the second strategy was getting common denominators, equivalent fractions with common denominators to prove that 16/24 is bigger than 12/24. So 2/3 is bigger than 4/8. Okay, let's try number 2. So let's see if we can reason this out a little bit. So I'm looking at this. They aren't the same sized pieces in the whole. This cake is cut into 6 pieces. This cake is cut into 8 pieces, so that doesn't help. But I noticed that the same amount is shaded, right? 5 of these pieces are shaded and 5 of these pieces are shaded. We have a common numerator. So I can reason this out. If this cake is cut into 6 pieces and this cake is cut into 8 pieces, and in this one I've shaded 5 and in this one I've shaded 5, then really what matters is which cake has the bigger pieces. Are 8ths bigger or are 6ths bigger? Now don't answer fast. If you answer fast, you'll look quickly and you'll say, well, 8's more than 6, so 8ths must be bigger. But 8th, imagine that the cake is cut into 8 pieces. Right, the cake is cut into 8 pieces versus this cake, which should be exactly the same size if I lived in a perfect world. This is why I tend to not draw pictures for comparing. This cake is cut into 6 pieces. Well, which slices are bigger, 6 or 8? If I cut it into only 6 pieces, they're going to be bigger pieces than if I cut into 8s. So for that reason, if I have the same number of pieces, then whichever pieces are larger is going to be the greater amount. And 6ths are bigger than 8ths. So 5/6 must be bigger than 5/8. Now, that's the first strategy, right? We just proved it. And again, you could do a picture if you can draw your holes exactly the same. You see, like you can see 5/6 is bigger. It's more cake than 5/8. You can see it. Okay, but you can also just imagine it because 8ths are smaller than 6ths are. 6 are bigger pieces of cake, and we have 5 and 5, so 5 pieces of a bigger cake pieces are going to be more. Now, let's say that's that's too much. Well, we can go this other strategy. We can get common denominators. Use the skill method instead of the reasoning. So we're going to times these each by a whole to get an equivalent fraction that has the same denominator. Now, I can't times 6 by something to get 8, and I can't times 8 by something to get to 6. So I'm going to have to count by these. I'm going to have to think of by multiples. And again, you don't have to write them out. If you are good with your multiples, then this should be pretty easy. If not, writing them out helps. 8, 16, 24, 32. Just counting by 8s. I'm going to count by 6s. 6, 12, 18. Ooh, 24. Aha. So I can get both of these fractions to equivalent fractions with 24ths in the bottom. So let's think about this. What times 6 equals 24? 4. This must be 4/4 because it has to be a whole, because 5/6 times a whole will give me an equivalent fraction. 5 times 4 is 20. So we've just proven that 5/6 is equal to 20 24ths. Now let's look at this. 8 times what equals 24? Well, 8 times 3 is 24, which means this must be 3/3 so that we get an equivalent. 5 times 3 is 15. So we've just proven that 5/8 is equal to 15 24ths. So what's bigger, 20 24ths or 15 24ths? Well, they're the same number of pieces, so 20 24ths is bigger. 5/6 is 20 24ths. 5/8 is 15 24ths. So for that reason, 5/6 is bigger than 5/8. Made 2 different strategies. All right, let's try the third one. Okay, we got 3 11ths and 2 9ths. This one's going to be hard. I'm just going to, there are ways to reason this out, but I'm just going to use my common denominator strategy because both of these are less than 1. Both of these are less than a half. I could maybe do a 4th, and I can actually I can see with 4ths. This fraction is a little less than a 4th because 2 times 4 is 8. So this is a little less than a 4th. This one's a little more than a 4th. 3 times 4 is 12. So 3 out of 11 pieces is going to be a little bit more than a 4th. So I can tell, or I suspect 3 11ths will be bigger. But let's check and see. So let's go 3 11ths and 2 9ths. We're going to times these each by a whole. Okay, and we want a fraction that has the same denominator because that's easy to tell which one's bigger. So, all right, if I think of all my 9s and 11s facts, what should be the first one that comes the same for them? So, like 11, 22, 33, 44, 55, 66, 77, 88, 99 seems to me to be the closest one. And same with 9, we go 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99. So they both can go towards 99ths. We can find an equivalent fraction of 99ths. Now, what times 9 equals 99? 11. So this has to be a whole. So we'll make it 11 11ths. 2 times 11 is 22. So we just proved that 2 9ths is the same thing as 22 99ths. because we times it by 1, and anything times 1 equals itself. So this must be this. Now when we come up here, what times 11 equals 99? Well, 11 times 9. So this must be 9/9. 3 times 9 is 27. So we've just proven that 3/11 is the same thing as 27/99, because we times it by a whole, and anything times 1 is itself. So which of these is bigger? Well, 2/9 is 22/99. 3/11 is 27/99. 27 of these pieces is more than 22 of these pieces. So my theory was correct. 3/11 is the bigger amount. Okay, let's try the fourth one. Ooh, I like this one because this one already has common denominators. Okay, I can see that this is 2 wholes. This one's a mixed number, and this one's an improper fraction. So with this one, I'm just going to make this. I could either make this into an improper fraction or this into a mixed number, and I'll know. So for this, I think about, well, 3/3 is 1 whole. Right, 1 whole is 3/3, which means 2 wholes would be 3 more thirds. That would be 6/3. I have 7/3 here. So 7/3 must be 2 wholes, that's 6/3, and 1 more third. 7/3 is the same thing as 2 1/3. And again, you don't have to draw this, but for those of you who like to see it. If I shade in 7 of these thirds, 1, 2, 3 thirds, 4, 5, 6 thirds, 7 thirds, see? It's 2 wholes, 1 whole, 2 wholes, and 1/3. 7/3 is 2 1/3. So the question is, what's bigger? Is 2 1/3 bigger, or is 2 1/3 bigger? Well, they're the same. This one must be equivalent. So what I hope you noticed is that the skill part of reasoning out fractions, the skill part is understanding how to multiply by a whole to get equivalent fractions. Okay, that's the skill part. There is also the reasoning part. Like here we used a benchmark. We said, well, this is a half, this is more than a half, so this must be more. For here we used a common numerator. We have 5 pieces shaded in each, but 6 are bigger than 8s, so 5 of the 6 is going to be more than 5 of the 8s. Must be bigger. For this, I used a benchmarks in my head, but I didn't teach you that because I didn't think most of you were ready for it. And then here, we didn't need much of a skill. We just had to change this improper fraction to a mixed number, and we could tell. So the thing is, thinking helps more than just following a rule. And so, I mean, if you want to follow a rule, you can just do these. But thinking can be really beneficial with fractions. If you have any questions, let me know.